everyone, I'm Nurul Hazrina binti Nordin from UMPSP Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan, the instructor for this course.
Chapter number 4 is scoring and game mechanics. At this stage, we will enhance our game by adding scoring system and refining game mechanics. In this chapter, you will implement a system to track player scores based on successful actions and introduce a game timer to regulate the pace and gameplay. The key programming concepts covered include using variables to manage score tracking, and understanding the importance of event timing in game development. By the end of this chapter, your game will have structured gameplay elements that provide feedback to the player. In programming, control flow is managed through three types of control statements, which are sequential, conditional, and iterative statements. Let's go through each one with a flowchart example. The first type of control statement is the sequential statement. This is the simplest form of program execution, where instructions run line by line from top to bottom in a predefined order. For example, consider turning on an LED, waiting for a second, then turning it off. The program follows a structured sequence without any decision making or repetition. Sequential execution is the foundation of all programs, ensuring that each line of code is executed in the correct order. The second type is conditional statements, such as if-else, which allow decision-making within a program. This is where the program checks a condition before executing specific instructions. For example, if a button is pressed, turn on an LED, otherwise keep it off. Conditional logic is widely used in real-world applications, such as security systems, smart home automation, and sensor-driven responses, where actions depend on certain conditions being met. Conditional statements like these if-else help us make decisions in our code. If a button is pressed, we can turn on an LED. This technique is useful for interactive projects like the smart home automation system and automation. Learning to handle this effectively enables more complex interactions between hardware and software. The third control statement is the iterative statements or loops. Loops help execute tasks repeatedly without needing to write the same code multiple times. For example, we use a loop to make an LED blink continuously, turning it on, waiting for a second, turning it off, and repeating the process. Loops are essential for automation and real-time systems like the traffic light controllers, sensor-based monitoring, and robotics, where tasks need to run continuously. Understanding these control structures, sequential, conditional, and iterative statements, is fundamental for writing efficient Python programming on Raspberry Pi. Understanding these control structures, sequential, conditional, and iterative statements, is fundamental for writing efficient Python programs on Raspberry Pi. By applying these concepts, you can develop an interactive and automated system, enabling your Raspberry Pi to respond intelligently to users' input and sensor data.
Let's look at the heart of our game development journey. Step 5. This step is all about collision detecting and scoring. As you'll soon discover, this is where our game truly comes to life, with elements interacting and scores climbing. Collision detection is the magic that happens when our player character interacts with the enemy character, making the game challenging and thrilling. But what's a game without a score? So in step 5, we'll learn how to create a scoring mechanism that keeps track of the player's performance. Step 5.1 is a pivotal movement in our game development journey. This is where we initiate Pygame, the powerhouse that brings our game to life. In this step, marked as step 5.1, we take the first step towards creating a dynamic and interactive gaming experience. Pygame is a Python library designed for creating video games. It provides us with the tools and functionalities to build games from scratch. And the gateway to this incredible world of game development is a simple line of code Pygame init. This function initializes the Pygame library, setting the stage for an endless possibilities. In step 5.2, we are diving into the world of scores, a vital component in any game. Scores not only track the player's progress, but also add competitive edge to the gameplay. Let's explore how we are initializing the score in our game. First of all, what is the score? The score is a numerical representation of the player's performance in the game. It can signify success, challenges, and the pursuit of improvement. To make the score accessible and modifiable across different parts of our code, we declare a global variable named score. We initialize the score to 0, a starting point from which our players can begin their gaming journey. As our game progresses, this score will keep track of the player's accomplishments, whether it's defeating enemies, achieving objectives, or collecting rewards. Score also ignites the competitive spirit. Players strive to beat their own records and climb the leaderboard, adding an extra layer of excitement to the game. Next is step 5.3. This is where we define the collision function, the magic behind detecting interactions and scoring. In this step, marked as 5.3, we unveil the logic that makes our game dynamic and engaging. So, what is collision function? The collision function is our game's detective. It's responsible for detecting when the player character collides with the enemy character. To ensure that our collision function can access and modify essential variables, we declare player, enemy, and score as global. The real action happens here. We check if the player's rectangle collides with the enemy's rectangle. When this collision occurs, we celebrate the player's achievement. Every collision is a point earned, a scoring mechanism. We increase the score by 1 when a collision is detected. It's this simple line that adds value to every player action. But what's a score without being displayed? So, we create a text label, score X, where X is the current score. To make it look good, we choose a font size, and font color. It's your chance to add an aesthetic touch to the game. And finally, we display the score label on the screen. It's a small but essential element that keeps players informed and engaged. The collision function is our game's watchful eye, as we have seen in previous slides. It's responsible for detecting interactions between the player and the enemy. In this step, we make the magic happen. We call the collision function within our game loop right here. When the player and enemy collide, the collision function doesn't just detect the interaction, it also celebrates the player's achievement. Every collision counts. Every time the collision function is called, the player's score is updated. It's this dynamic aspect that keeps the game engaging. With the collision function in action, we are now tracking player accomplishment and adding an exciting dimension to our game.